Hello everyone. So today we'll discuss the concept of ocean waves. Now the motion of ocean water can be classified into two types. One is the horizontal motion and the other one is vertical. Now what horizontal motion can further be classified into two types, that is waves and currents. And vertical can further be classified into two types, that is tides and upwelling. So today we'll be discussing ocean waves. Now, what is a wave? Wave is a rhythmic movement that carries energy through matter or space. This we study in physics as well, right? But in case of ocean waves, these are the undulatory motion of a water surface. You can see it here, the crest and trough. This is the undulatory motion of water surface. Okay. Now there are different terminologies related to waves, right? So the first one is the crest. You can see it here. This one is the crest. Crest is the highest part of a wave. Now trough. This one is the trough, the lowest part of wave. Okay, and wavelength is the distance between these two adjacent crests or two adjacent troughs. Okay, now the wave height. Wave height, you can see it here. The wave height is the vertical distance between the lowest part, that is the trough, and the highest part. You can see it here, that is the crest. So this one is the wave height. Okay, now frequency is the number of complete waves that occur over a given period of time. Now, for example, if you have to calculate the frequency of this wave, so you will calculate the number of wave crests that pass from point A each second. So that will help us in giving the wave frequency. Okay, and this is usually measured in cycles per second. Okay, now amplitude is half the wave height. We have already discussed what is wave height. Amplitude is half the wave height. Okay, now there's another terminology, that is wave period. Now wave period is the time required for the wave crest at point A to reach point B. You can see it here. The time required for the wave crest at point A to reach point B will be wave period. Okay. Now, what is the reason behind these waves? Now, see, most of the waves are generated due to the wind. These winds blowing over this water surface, it actually drives these waves, right? So, friction from the wind moving over the water surface causes the water to move along with the wind, right? Now, how it happens? See, if the wind speed is high enough, the water begins to pile up. If the wind speed is high enough, it will pile up, right? And then it will form. So, this is how the crest and trough is formed, okay? And that produces a wave. Okay, now as the wind velocity increases, the wavelength, the period of wave, and the height all will increase. Okay, so the main factor is the wind velocity or the wind. Okay, now this is how this water moves in a wave. Now see, this one here you can see it is in the form of orbital motion. So water molecules move in an orbital motion as the wave passes through them. Now you can see it here, this one is the wave, this is the wave direction, right? And see the water molecules, how they are moving. They are moving in the form of circular orbits, right? And these particles of water move around in circles that we've already discussed, right? The farther below the surface, the smaller the circle. You can see it here, the farther below the surface, the smaller is the circle. Okay? This one also clearly shows this, that this diameter of orbit, it increases with the increasing wave size, but it decreases with the depth below the water surface. Okay, you can see it here, the diameter of the orbits here and the diameters of the orbit here, right? Okay. Now, what happens when the wave reaches the shore? See, when the wave reaches the shore, it experiences friction, right? And that is why the wave slows. Okay, so when the wave will slow down, its crest and trough will come closer together, right? And that is why it will be it will be in the form of this protruding, right? Now, how this happens? See, the top of the wave is not slowed by friction, but the bottom of the wave experiences friction, right? That is why the top moves faster and the bottom moves slower, right? That is why this wave, it breaks at the shore. This is how it breaks. Okay. Now there are different wave types. It depends on the depth of influence, right? It depends on the period, it depends on the wavelength, and definitely on the source, right? Now some waves are just ripples, right? You can see it here, micro ripples and ripples. Now the reason may be light winds or some insects, right? Now these are very shallow. You can see it here, the micro ripples and ripples. Now then the other one is chop. Now the depth of influence here is shallow, right? You can see it here, the depth of influence is more. Okay, now then there are swells. These are well developed waves, right? And these are the source for these swells are storms, right? Then there are tsunami. These are very high waves. Their height may reach up to 30 meters, right? And the depth of influence is to the bottom. Okay, the reason may be earthquake, landslides, volcanic eruptions, etc. Tsunami, we'll discuss it in another series, right? Now, what is the action of wave at the shore, right? See, wave forms a number of depositional landforms. You can see it here. Beach is a kind of depositional landform, and wave also forms erosional landforms. Okay. Now, so waves when they reach the shore, they keep on cutting or eroding this coastal land, and then it leads to erosional cliffs, right? These are the resistant land that is known as headland, right? And then there are these. This one is bay. Here it is a beach, right? So the different kinds of depositional as well as erosional landforms are formed at the coast, and that is because of the wave action. Okay. Thank you.